now going to talk to you about prosthetic devices. Prosthetic devices are things like robotic limbs, and what they do is they allow more control and mobility than traditional plastic prosthetics to users who have lost an arm or a leg or a hand, or etc. An example of a prosthetic that is currently still in its design phase, but yet it is still being implemented in some certain cases, is the prosthetic named the Luke arm, and it was developed by Dean and Kamen and the DEKA team, and it was designed for returning U.S.-Iraq veterans. The Luke arm is special because it allows a 14 degrees of rotation, and it allows very finer control than what is previously experienced in prosthetic limbs. And it is also ergonomically designed because it has special pads that tighten their grip when the arm is under load and loosen when the arm is not under load. And what's so unique about this is this reduces the traditional pain of prosthetics that the user experiences because they are able to loosen and tighten the grip that the prosthetic has on the patient's arm. And it is also controlled by sensors in the user's shoes. The Luke arm provides feedback to the other users, and these are done through pads in the arms that vibrate with different intensities depending on how strongly an object is being gripped. Because if you think about it, the prosthetic arm has no real sensors in it, so the user actually has no feeling in their fingers, but yet they are still able to move their fingers and pick up things with their robotic hand. But because of this, they have to have a way of being able to sense the actual strength of which they are picking up things to even know that they have something in their hand unless they're looking at it. And it also allows soft objects to be grasped, such as bananas and grapes. And so these little pads that vibrate are very sensitive to any kind of pressure that they are being forced upon. How other prosthetic limbs are controlled? There are basically two other kinds of ways. One is through the myoelectric system, which is where it registers the electronic signals in the wearer's muscles to move the limbs. And another one is called the neural control, and this is when they attach sensors to the nerves in the shoulder, and basically whatever you think, you do. And these sensors can be attached to nerves on any part of the arm, not just necessarily in the shoulder. And this is really good because this way you don't have to have sensors in the bottom of your shoes that control your arm. You literally just think and your arm reacts. An example of a neural controlled hand is a device called the Smart Hand, and this Smart Hand device has been under 10 years of research and is just now being released, and it currently only has like a handful of test subjects that is being used on, but it has shown very promising results. And that is because the hand has 4 motors in it and 40 sensors. And these sensors are very unique because they not only provide motion, but they also provide sense to the user. And this is the first device of its kind that allows the users to sense what he or she is doing, so they actually have feeling in their prosthetic hand. And how this is possible is that the sensors are connected to the nerves in the stump of the arm. And so you literally go in and you surgically kind of implant this hand onto your real stump. And you connect it via the nerves, and so whenever you do stuff with your hand, it sends the nerve impulses to your brain which register them. And this is kind of a breakdown of the differences between the Smart Hand and a biological hand. These are the current differences, and as you can see, the Smart Hand only has 40 sensors, while the biological hand has millions of nerves in your hand, so you can have a much more wider range of feeling and sense in your hand. Also, the Smart Hand has limited range of motion, while the biological hand has full degrees of motion. The Smart Hand has a limited variation of applied strength, while the biological hand has variation of applied strength. So basically what this chart just shows is that Currently, biological hands are still superior over to smart hands because you have more nerves, more degrees of motion, and more strength. But however, with prosthetics, with the increase in our abilities with them, it kind of proposes some questions about the future. And these are, what if artificial limbs become greater than biological limbs? Also, what if people turn their whole bodies into bionic bodies? Would such people be accepted as authentically human? And so these are just some kind of questions that are being brought up as prosthetics are becoming more and more common. And current challenges for all developers, this is to reduce cost, because currently to get a true robotic hand or like something like the smart hand, it costs a lot of money. And also they need to make the devices more available to those in need, so those that just don't have, for those who don't have that much money. And they also need to create permanent devices that don't have to come off, because currently, normally when like the user goes to sleep, they would take off their prosthetic arm or leg. And so in the future, it would be really good if those devices did not have to come off periodically. And here's my bibliography. I use a website and the Informational Technology in a Global Society for the IB Diploma by Stuart Gray book.